Just a second, please. Okay. So first of all, we are going to define what exactly is energy. Okay. Energy can be defined as the capacity to do work. Now there are different sort of energies, right, that we need to learn. Before that, I just want to tell you that energy, SI units, all energies have the same units, which are called joules with capital J, and energy is a scalar quantity. A scalar quantity means that it does not have a particular direction, just the magnitude and unit. Okay, now, so we're going to talk about some types of energies today. So first we are going to talk about potential energy, then we're going to talk about kinetic energy, we are going to talk about chemical energy, we are then going to talk about nuclear energy, talk about electrostatic energy, and we also would like to talk about internal energy. Okay. So potential energy has three different forms. First one is gravitational potential. Number two is the elastic potential, which is also, by the way, known as strain energy. Okay. And well, we can define electric later, never mind. So gravitational potential energy is defined as the work done by gravitational force. Elastic potential energy is basically work done in changing shape, so basically gain or lose energy. Kinetic energy is defined as the energy due to motion or movement. So if somebody or a body is moving, it must have kinetic energy. Chemical energy is the stored energy within reactions, right? Nuclear energy is basically energy in unstable nuclear reactions. Okay. And electrostatic energy is the electric energy that moves charges, right? Internal energy is also known as the thermal, or some people also call it heat energy, like that. Is it clear, everybody? Anybody wants to know anything? Let me know. Otherwise, please write this down. Okay, everybody has written it? Okay. Now you guys need to understand that energy transfer is done through many means. Okay, we'll talk about them in a bit. So some means are called mechanical work. Okay, in mechanical work you guys need to understand that energy is transferred by forces. Okay, what I mean by this is, let's suppose if somebody is like, there is a motor that pulls a mass or maybe a slab to the second floor, so of course you need force and some distance is moved. That's why it's sort of a mechanical work, right? Then electrical current. The electrical current basically causes energy to be transferred by charges in a circuit. That could be electrical current. And then there are other things as well, that like heating. So by heating, they're like conduction, convection, and radiation can transfer heat, transfer energy. Okay, so these are the processes that we need to learn, and as we progress we are also going to learn about each of them, that how they do it. Then by waves, and waves basically could be transfer of energy in electromagnetic, sound, and other waves. So basically waves also transfer certain energies and we use them all the time, they're like happening. Is it clear, everybody? Who can tell me how light from the sun reaches us? Somebody tell me, please.
Radiation.
Yes.
So it has no vacuum.
Light reaches by waves, and the type of wave that does it is electromagnetic wave. Is it clear, everybody? So everything that is happening around us basically comes from certain process that I've listed. Okay, please write this down.
What's the title? Work energy power.
Yes, work energy power. Okay, now, so the next thing we're going to do is basically we're going to learn what is the formulas for gravitational potential energy, and we're also going to look at kinetic energy. Now, gravitational potential energy, as you know, it basically is the work done due to gravitational forces. So in short, we write it as gravitational potential energy as GPE, and the formula for this is mass times gravitational field strength times the height. So we could write it as GPE equals to mgh, and by this time you should know the gravitational field strength is 9.8 meters per second square. Everybody understands this?
Yes. Yes, sir.
Okay. Now, then we go to kinetic energy. Kinetic energy is written as Ke, and it is half times mass times velocity whole squared, like that. Okay, so that's square. Okay, in short, we just write it as half times half mv squared, like that. Now, because all energies have the same SI units, and SI units would be joules, so you just got to remember that. Now, let's do a question and see how well we understand this. So it says, a mass is lifted by a motor that does 600 joules of work. If the mass is 20 kgs, what is the height it is lifted to? Can you guys find it, please?
Sir, I got the answer.
Yes.
2 meters.
2 meters. Okay, let's see who else can find it. I don't think it is 2 meters, but let's see. Awais, Caroline, Ali, Chavez, Sen. I think you forgot something in the formula. That's why you're getting that answer.
Give me time to figure it out.
Okay.
So it's 2 meters.
It's 2 meters. Okay, let's check it out. So if it's being lifted, we got to use GPE, which is mgh. This is 600 joules. The mass was 20. G is 9.8 and height is h. Right? So we got to divide these. Where is my calculator? 600 divided by 20 divided by 9.8. That should be 3.06 meters, not 2. What did you guys do that you got 2?
3 meters, sorry. Sir, I used 10 instead of 9.8. My school, they used 10.
10 is from the old syllabus now. Your syllabus changed last year. Okay.
No, even I got 3.06 in the first.
Yeah, that's
But
good.
since they said 2, I didn't say it.
Okay, that's if the majority says something, you should not follow it, I guess. Okay. Do what you do the best. Everybody must stick to 9.8 from now on. From last year, it has changed. Okay. Do not use 10.
Sir, I said 3.
You said 3? Okay.
Yes.
Okay, that's good. All right, now we move to another part, which is basically law of conservation of energy. And like I said in the previous class as well, law in physics means that you cannot change it. It has to be there. And in this law, it states that energy can neither be created nor destroyed. Okay. It can only change from one form to another. Okay, now what it means is, let's suppose there was a skater boy. Oh no. Okay, and this is the ramp he's skating on. Okay, let's make a boy with skates. So because right now he's at a height from the bottom, what kind of energy does he have? Who's going to tell me?
Sir, which position? To the bottom or
Here, where you see him.
GPU?
So he has gravitational potential energy, and when he goes down, reaches the bottom, so naturally he's going to gain speed, right? So how did he gain speed? Because the gravitational potential energy changes to kinetic energy. Is it clear, everybody?
Clear.
Okay, now another example. So there is a car Okay, let me practice some of my, drawing skills as well. Okay, so there is a car that is filling up petrol. Okay. What kind of energy is there now? Who's going to tell me?
Sir, for the car,
Yeah, when you fill up the petrol, what kind of energy?
Chemical.
Sorry?
chemical.
Chemical.
That's
Exactly.
chemical, yeah.
That's very good. So right now it has chemical energy because in the petrol is going to get heated up, react, and then cause the car to move. So when the car moves, this chemical energy converts to kinetic energy. Is it clear, everybody?
Yes.
Okay. Now last example. So, who likes to jump on his or her bed? Nobody? That's not possible. I don't believe you. When I was your age, I used to jump on my bed, on my mattress. So if somebody is at a height, he jumps up, is at a height here. What kind of energy does this guy have?
Well, if he jumps, he's gaining GP.
Yes. And when he hits the mattress again, the mattress becomes like this. Right? So mattress is deformed, changes shape. So what kind of energy does the mattress gain? So this changes to?
Does he have elastic potential?
Yes. Strain energy, elastic potential. Is it clear, everybody?
Clear.
Okay. So this means that all energies can change into one another. But sometimes something else also happens. So we should remember that some of the energy might go to things that we don't really need. For example, in this car example or any example here, there might be sound or heat, right? So we don't need that. So suppose that there was an input energy and of course from some energy change you would want some useful energy to be there or useful work, right? So some of the energy goes into usefulness. So useful energy is converted, like we put chemical energy into car and then we want it to move, so kinetic energy. But some of it basically converts to unwanted energy. Okay, that doesn't look nice. How do I write it now? Okay, unwanted energy. And that could be like the car gets heated up, it also makes sound. So not all energy is converted to usefulness, right? This diagram that I've made, this is called the Sankey's diagram, that basically displays how the energy and in what form wanted and usefulness it is converting. Is it clear? So
Right.
Yes.
Now let me give you an example, and from that we will learn. Okay, suppose we have a track like this, okay, like that. This height is say 5 meters. This height is 2 meters, okay. A ball rolls onto this like that and reaches here and stops, okay. Now they have given us a couple of points. So they say this is A, the bottom one is B, and this is C. So they want us to tell us the principal energy changes first from A to B and then B to C. Okay, who's gonna tell me? And by the way, this is a track with friction. Yes, who's gonna tell me A to B?
Gravitational potential.
Okay, so initially at a height it had gravitational potential energy, and then when it reaches B,
Gains a lot, like kinetic.
it gains kinetic, and that's it. Also, it would release some heat. Why? Because of the friction here. This is basically the unwanted energy that has happened. Is it clear? Okay, now from B to C, what happens?
B to C, would it be kinetic energy to GP?
So kinetic energy, okay, goes to GP. So useful is here. Does it release heat or no?
No, I don't think so.
Yes, it would still release heat if it's friction there. Okay, this is the reason, if you understand, right, that if it was initially at 5 meters, it would stop at 5 meters again, but now it's stopping at 2 meters, so it means some of the energy must be lost to the surroundings, right? So it must be converted to other forms that you don't want. Is it clear, everybody?
Yes.
Now if I want to draw a Sankey diagram, and that's the last thing we're going to do today, okay, that would be in the whole process, right? For the first one, the Sankey diagram would look like this. So we would write GPE here and kinetic here and heat here. For this one, it would be like this. So kinetic here, GPE here, and heat here. Is it clear, everybody?
So this is called Sankey's diagram.
Sorry?
This is called Sankey's diagram.
Yes.
Okay.
Sankey diagram is like this shape, okay? It could be more complex, but in our course, not that complex. Is it clear?